Assignment 12 that we took some of the notes on but didn't finish. That was 2 classes ago. And then I have the Unit 1 review for you, and I want to give you more directions about that. But mostly that is it's a review. A couple of each question types remind you the stuff we've done and hopefully help you identify where your studies needs to be. Now, our quiz is not next class. The date's been up there. It's the class after that. But I try to get you the review a little bit earlier in case you need to buckle down and spend a little bit more time. Okay. Jacob, Max, Henry. Max, Henry's not here. Okay. Nora won't be here today. Braxton and Henry are still not here. Okay. Last call. Any other 11 and 13s? Okay. Good deal. Okay, so assignment 12, we started talking about the definition of continuity. So let's spend a second here talking about what we've already talked about, and then there's a little bit more notes to that. Okay, so here's our notes from continuity. So just being able to look at a graph and see that it's continuous or not continuous is really not enough. That's not typically, these are not typically yes/no questions. They're typically, is it continuous or not continuous, and justify your answer. So we have to know all 3 parts of this, and hopefully you took some good notes to help you see why each one of these is needed. But basically it's got to approach the same y value from the left and the right. So the way to say that in calculus is the limit from the left approaches the limit from the right. If you have a hole there, then that's a break in the graph, so there has to be a hole there. At x equals c, that point must exist. And what I have going on over here, I still just about have that here still, so let me do it. Just because the limit exists, just because the point exists, if the point is not the same as the limit, then this is still a momentarily break in the graph. So this last one is saying that you've got to have a point at x equals c, but it better also be equal to the limit. 3-part definition. All that sound familiar? Okay. So as you practice these, again, we got a little bit more notes here to do. But when you get to practice these, you need to try to quiz yourself each time. If you're trying to prove something's continuous, try to use all 3 of these parts without looking back at your notes. And then each question, if you look at your notes less and less, then by the end of the practice, you probably are aware of the 3 pretty well. Okay, the parts we did not talk about though is identify the type of discontinuity, if any, and where they occur. That's good. So first off, I need you to understand that 3x plus 1 by himself is continuous. That's just a linear, I don't want to try to graph all these, but y-intercept of 1 and a slope of 3, it looks something like that. That guy is continuous. And x over 2 minus 1 is continuous. That does not mean that the function is continuous though, because I could have a continuous function, red, I could have a continuous function, green, but is this whole thing continuous? Okay, what could I do to this red piece to make it be continuous?
Connected to the green one.
Okay, connect it where? You need this point to be up here, right?
Yeah.
So the end of the first piece needs to be the end or the beginning of the second piece. You need these to be connected, right? So that's really all we're going to be doing. We're just going to be doing it algebraically. I need 3x plus 1, which is continuous, to be the same as this. But I don't care if they have the same y value normally. I only care if they have the same y value when they connect. So I really only care that they have the same y value when x is 4. So if I plug in 4, I get 13 on the left and 2 minus 1 on the right. Well, 13 does not equal 1, so what does that mean? Very good, it's not continuous. This guy is approaching 13 at x equals 4, and this guy is approaching 1 at x equals 4. So again, that's like saying you've got a continuous function, but this guy's all the way up here at y equals 13. This guy is a continuous function, but he's only down here at 1. These are not the same y value at x equals 4 when I need them to be. I need these pieces to be connected. So this would be not continuous or discontinuous.
How do we abbreviate that, or do we?
I'm sorry?
How do we abbreviate that, or do we not abbreviate it?
The not continuous?
I would have left to abbreviate that.
I mean, I guess you could. There's not like a acronym or anything, so. You don't get taken off for spelling. I'm sure I've spelled continuous and discontinuous 5 different ways in here, so. But I never claimed to be a good speller. Okay, but there's another part of the question. If this approaches 13 from the left and this approaches 1 from the right, what type of discontinuity is that? There you go. The graph is jumping. The y value is jumping at an instant. So notice they said what identify the type as well. So yesterday I got a few of that same question. How do you know that it's jump instead of removable or infinite that we practiced a lot yesterday? Well, there you go. If you had a piecewise function and you can see it's approaching one y value from the left and a different y value from the right, then you know it's jumping at that instant. Okay, let's look at another one. So this is a 2-piece piecewise function. This is a 3-piece piecewise function. So independently, the top is a polynomial. So he's already continuous. Polynomials are always continuous. X minus 1, you should know what that graph looks like. He's continuous. And the line y equals 5, that's a horizontal line, he's continuous. But just because each of these parts are continuous doesn't mean the function as a whole is continuous. Again, instead of just saying do this algebraically and then here's how you get your answer, you need to understand why I'm going to do this algebraically. Okay, I'm not going to pretend like I know what any of these are, but if the top is continuous and the bottom is continuous, or the middle and then the top is continuous, this is not continuous. I need these two to connect just at this point. I don't care if their y values match up any other time, but when it stops being the red function and starts being the green function, x equals -1, I need these to have the same y value. I need these to connect. Also, over here, I need the middle function, which I have as green, to be equal to the, this is just a constant, so I know what that graph looks like a little bit better. But I don't care if they have the same y values, except when it stops being the middle function and starts being the bottom function, x equals -1. If I want this to be continuous, I need these to have the same y value at that time. So what I'm about to do is erase this, and algebraically I'm going to set the top function equal to, okay, I have no idea why that disappeared. I need to set the top function equal to the middle function at x equals 1, And if I get the same thing on both sides, that means that the y value here at x equals -1 equals the y value here at x equals -1, and that means they're connecting. That's a good sign for continuous, not a good sign for discontinuous. Then over here, I'm going to have to set this middle part equal to the bottom part. I want to see that they're equal, and I'm going to plug in -1 for x because that's when I care that they're equal. And if I get the same y value at x equals -1, that tells me they're connecting. If they're connecting, then that's a good sign for continuous, and if they're not continuous, then, or if they're not connecting, it's not continuous. Okay, so all of that, hopefully that helps you understand why we're doing what we're doing. But really what I care about is when does this top function compared to the middle function, are they the same y value when it stops being the top and starts being the middle? At -1. Plug it in over here. 1 plus 2 is 3, minus 1 is 2. Plug it in over here, we get -2. Those are not the same value. He's approaching 2 from the left, -2 from the right. So it is discontinuous at x equals -1, and it would be a jump. It's going from y of 2 to a y of -2 at an instant. Jump discontinuity. Yeah.
Are you plugging in 1?
-1.
I think the top is also -2.
Yeah, that's what I got.
Okay, thank you. So my arithmetic is off here. So this would be +1, -2 would be -1, minus another 1 would be -2. Thank you. Okay, thank you. That's obviously important. So just because you guys are going to see this theme throughout the year. A lot of times just because you know what you're supposed to do and you might understand the calculus, a lot of times the algebra, or in this case the arithmetic, can still make you miss things, which is where calculus can be frustrating sometimes. Okay, so those have the same y value at x equals -1. So can I say g of x is continuous now?
No.
Oh, sure.
Because there still might be a break handing off from this middle function to this bottom function. So I want the middle function and the bottom function to be the same at x equals -1, where it stops being the middle function and it wait, yeah, I should be comparing something different, shouldn't I? Maybe I didn't list these. Oh, this was in the middle. This one's actually in the middle. If you think of this graphically, this stuff is far left, this is in the middle, and this is far right. My visual was just off. Okay, but I need that to be the case either way at x equals -1. So that would be -2 equals 5. So unless my arithmetic is off there, that's not the same. So those are not connecting. I would say that's a jump discontinuity there. Okay, I lied. I'm sorry. These being out of order, at least visually. Usually this is the top is the far left of the graph, the middle is the middle of the graph, and the bottom is the bottom of the graph, but they don't have to be. So now that I'm thinking about this would be the far left, some kind of quadratic. This is just y equals 5 only at that instant. So at x equals -1, this I already figured out was -2. At x equals -1 though, it is 5. There's no variable in there, it's always 5. So what's really happening here is, let me draw a better picture. These two do have a limit. This approaches -2 and this approaches -2. This is at x equals -2. They're approaching the same value. But at x equals -1, at that instant, again, this one's really visually in the middle, it's y equals 5. So if these are approaching, this is at x equals -1. If this is approaching -2y value and this is approaching -2y value, and then all of a sudden there's a point up here at 5, it's still discontinuous, but it's for a different reason. Now the whole graph's not jumping. What type is it if it's something like this? Very good. If you've got a hole, whether the hole exists somewhere else or doesn't exist, we call it removable discontinuity. I should switch those two, I guess. Removable discontinuity. So again, obviously I know how to deal with the piecewise functions. I obviously know the definition of continuity. If you're not careful though, you can still make mistakes. Never a good idea to rush. I didn't feel like I was rushing here, and I still wasn't super careful. So there's a lot of things I had to think about and a lot of things I had to verbalize. But at the end of this question, notice that algebra is not too bad. I wanted to see if these two approach the same thing at this x value, so I set them equal to each other and plugged in the x value. That told me they were approaching the same thing. But that's only the first part of the continuity definition. You also need a point here. A point. Second part of the continuity definition made sense, but the third part was messed up. The limit was -2, the point was 5. The limit didn't equal the point, so the third part of the continuity definition got messed up, and that's why we would say it's not continuous. Okay, so you can see why those are good practice. Okay, and then question 4, this should be our last example, and then you can start trying these and see how you think about them. Okay, so we've got some function h of x. It's a piecewise function. Part of the piecewise function is 2 minus x squared. Part of it is 4x plus k. What value of k would make h continuous? Well, I guess if this was these type of questions, this is what AP likes to do. It's like, okay, you can do the skill, you got an idea of what limits are, but do you understand it well enough that let's throw something crazy in there like k. Tell me what k has to be to make this be continuous. And all of a sudden, it's not one that you got to practice 50 times. It's a version of a skill that you practice 50 times. So, to be continuous, well, I would also say if this was multiple choice, like it would probably be on a test often, if nothing else, you could just say, well, if choice A says k is 12, you could try to plug in 12 for k and try to work it like 2 examples ago. And then if that doesn't work, you'd have to try choice B. If that doesn't work, you have to try choice C. But just from a test and test-taking strategy, that would make sense. But to be continuous, what has to be true about the top function and the bottom function at x equals -2? Right. The limit, whatever it's approaching from the left, has to equal the same as from the right. Now, k is just a constant, so this is always continuous, this is always continuous. The whole thing could be continuous if these two connect at x equals -2. So, like above, I want to see, does this function equal this function? I could care less about their y values except when it stops being the top function and starts being the bottom function. So at -2. So I get 2 minus 4 equals -8 plus k. So k must be 6. So it's not too bad, but again, when you first read that, it's like, what are they talking about with k? How do I even approach that? You just have to start it the same way. You have to say, all right, to be continuous, I'm going to test the first part of continuity. And if that's not enough, you might need to make sure there's a point there, the second part. And that's not enough, you might need to make sure the point and the limit are the same. So even when they throw in some weird thing like a variable of k, just start doing it the same way, and then you get something that you can solve for k to where it makes sense. And then, of course, if this was a test, and you finished and you had an extra 10 or 15 minutes, you could plug it in here and just make sure that it does actually work. Make sure you don't have a careless arithmetic mistake like I had a question or two ago. At x equals -2, this would be 2 minus 4, and this would be -8 plus 6. That's what I wanted. I wanted them to be equal. You good with that, Buzz? Okay. Okay, so please go ahead and try on the next page. Again, this is our first focus this morning. The other handout we'll talk about here in just a bit, but I need you to practice this. So this is really like 2 questions here. For you to know if it's continuous at x equals -1, you need to quiz yourself on the definition. Try to flip back to your front page less and less each question you learn. To be continuous, the limit from the left has to equal the limit from the right. So you should be thinking about what part of the piecewise functions you need and put that on your paper. Even if you can do that arithmetic in your head, I can do that in my head. I can see they're equal. You need to make a habit out of writing it down. That's what they're going to expect on the free response. Then I know I need to make sure there's a point there, and I need to write it on my paper showing that I thought about there needs to be a point at x equals -1. And then if the limit existed and the point existed and the limit equals the point, say it's continuous. And if it's not, tell me which one of those didn't work. And then do the same thing with x equals 2. So again, this one's kind of like 2 different questions, but this is also really great practice for piecewise functions. So if you don't feel real confident with those, hopefully you feel a little bit better about them after this. I'm gonna check over the homeworks for a few minutes real quick, give you a chance to get a couple of questions under your belt, and then as soon as I have the homeworks graded, I will offer to work any of the first few on the board if you're having trouble with them.
I'm not sure I've got my name.
There's a lot of no names on here. I don't know, I might have put it on the bottom or something. Let me just see what I've got first, and then I'll tell you. I didn't see it right away. Homeworks are taking me a little bit longer than I expected, so let me pause for a second. Anybody stuck on either part of number 1? Want me to go over that as a reminder for you? Everybody's feeling okay with number 1 still? Okay, what about number 2? Again, to only ask please if you've already tried it, because if I just go over it, then you're not getting everything you need out of it. Okay, I can't imagine many people would be to question 3 yet. Has anyone tried 3 and know you got stuck on 3? Okay, great. I'll go back to the homeworks for a minute.
So I don't have to write like any more here if I have the work right here, right?
Well, at least draw me an arrow or something
Okay,
so I can
just
see
like an
that.
arrow, okay.
Yeah, that's fine. But yeah, you don't have to rewrite it for me, but I want to be able to see that you know why.
Mr. Thompson.
Yep.
So for this one,
Uh-huh.
if it's coming in from the left at 2, and then it goes
-2.
or yeah, sorry, at -2, and then it goes to 3, and then it goes to negative radical 6. Is that removable and a jump, or is that just removable?
Well, it sounds like it's approaching -2 on the left. At that instance, you've got a different point of 3.
Yeah.
And then after that, so here's how I'm thinking of it. I don't know what these look like, but you've got something continuous, then some other point, and then like that.
Yeah.
This is, I would call
that's
that a jump.
Okay. Cool. Thank you.
Hey, Mr. Townsend.
Yep.
I think this was put in as a 0 on here.
Oh, okay. Easy fix. Thank you for checking.
Thank you.
Stress.
Yeah, sorry.
On 4,
Uh-huh.
I got yes there, no there.
because I thought pi over 2 approaching from cosine would be 0, and from tangent, isn't it?
Tangent sine over cosine.
Okay, yeah.
So that would be
Undefined.
Right.
And then
so. Okay, sounds like you guys are having some good conversations there. Is there anything
As you're discussing that you want me to clear up? Yeah. Sure, I would be happy to. Now, when, again, I know it's early in the morning and all that kind of stuff. I know you guys are usually tired. I try not to force a lot of participation out of you. That's why I ask you to try to participate when you feel more comfortable, so I don't have to do that. I don't know what that has anything to do with what I was going to say, but if you're not quite to question 5, oh, I know what I was going to say. So that's great. I love that you guys are helping each other, discussing things. You know, that probably helps you learn better than me talking up on the board. You get plenty of that. But when I go over a question like this, I do insist that you guys kind of, even if you're not on this question, even if you did this question and did it great, just keep working independently, please. Partly because I need to make sure everybody can hear me well. That did need help with this question. And this is one I'm 99% sure I don't have a recording of on the class website. So if somebody else asked about number 5, somebody else may ask about it later today. And so I'm going to record a video, and then it'll always be there for those people. So anyway, so please also hold your voices for that. Okay, so for each function, we're going to try to figure out the type of discontinuity and where it is. So this is continuous, 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 at least where they exist. Each part is continuous, but depending on what the y value is at -2 here, it might not be equal to the y value of -2 there, might not be what the y value is approaching from -2 over there. So this is where we need to think about the definition. So the first part of the definition, there's not really a first, second, and third. I just always list them in the same order. But the first part is I need to make sure that the limits exist. So right here, where it is approaching -2 from the left and it's approaching -2 from the right, I need to make sure those are approaching the same value. So the limit as x approaches -2 from the left, I'm going to compare that to the limit as x approaches -2 from the right. So from the left would go up in the top. This would be -8 plus 6. So that would be -2. And then from the right, we would get 4 plus 6, which would be -square root of 6. So I already figured out one thing. Since it's approaching this number on the left and this number on the right, that's a jump. So there's a jump discontinuity at x equals -2. You okay with that? Now, technically, other parts of the definition are also messed up. There's also supposed to be a point at -2, and there is, but the point's supposed to be equal to the limit. I don't have to state that. Again, you have to justify that something is continuous, you better state all 3 things. If something's not continuous, you can quit as soon as you find anything that's messed up. It only takes one part of it to be messed up to not work. Okay, the other part that I'm concerned about, though, is at because it says find all of them, is at -4. So just because these two naturally are continuous on their own, the y value of this at 4 and the y value of this in 4 could be different, and it could be another jump. So I've got to test that also. Okay, I messed that up. That's okay. So if I plug in, I need to not be lazy. As it approaches 4 from the left, I get negative square root of 18, I believe, unless I'm doing that too quickly. And the limit as x approaches 4 from the right would be the natural log of 4. Are these two the same thing? No. So we know it's not continuous or discontinuous at x equals 4. And what type of discontinuity would it be?
Jump.
It's a jump. If the y values are different, it can't jump at an instant. So jump discontinuity at x equals 4. So I would think it would list both of those. Okay, are we close there? Somebody have the solutions pulled up, verify that that's okay before we move on. It's okay. Okay, did you get what you needed out of that? Okay. Okay, if he was going to ask about 5, there's a good chance somebody else was going to ask about 5. So, anybody else that was going to ask about 5 need anything else you need me to discuss about this one before I take another question? Yes. Yes, that is also true. But what is the limit though? Yeah, so why not just quit there? Why not just quit with the first thing that you test? But yeah, technically the limit doesn't equal the point either. But if something's not continuous, you only have to show one part that's messed up. You don't have to show everything that's messed up. So you only have to show all 3 parts if you think it's continuous, because it's not a full, complete explanation without addressing all 3 things. But if you see it's messed up with one thing, just that's all you have to show. Okay, let me offer one more question for now. Yes.
On
You're first.
number 4,
Uh-huh.
when it's asking if x is continuous at pi over 2, is that a jump discontinuity or an inverse discontinuity? Because it's jumping, but it jumps 2 infinity.
I don't know about that. I don't know that it's jumping. So let's see. Just this part you're looking at? Okay, so the limit as x approaches pi over 2 from the left versus the limit as x approaches pi over 2 from the right. Let's see, from the left, this would be cosine of pi over 2, which is 0. From the right, that would be tangent of pi over 2, which is, okay, technically it goes up forever. If you know what the tangent graph looks like, you could know that that's infinity, but again, infinity or negative infinity, it's better to just say does not exist. So, if your graph, this is not a hole, so it wouldn't be removable. For a hole only occurs when you have a fraction and some value of x makes the numerator and denominator 0 at the same time. This is approaching 0, and then it just falls off the cliff, like it goes to infinity. So I would call that a jump.
Alright. If on the piecewise function, if you switched the greater than or equal to be on the middle function instead of the top one, would that, or like we have a little line under it,
Like right here.
would that change what it was? Yeah.
Because the limit from the left still has to equal the limit from the right. So
Or would that change which kind it is?
it would not.
Okay.
freeze my screen here for a second. There's one thing, if I can figure it, if I can remember a quick way to do it, I'll show you. It's a little bit of a calculator trick.
Just tangent is sine percent. It's been from tangent to sine. Well,
I got 0. Because sine would be opposite over a copy of this one. It should be plus over 1. Zero.
yeah, point 1 so it'd be negative 1 over 0. Right. No, it'd be 0.
Because we're looking at the triangle.
0. Yeah, that would be that'd be 0.
Okay, sorry for the delay there. There's part of the calculator thing that I wanted to show you that I didn't remember. If this isn't something that you can use all the time, but your calculator can actually graph piecewise functions. And I think if you update your calculator, I think they made it where it's pretty easy and they make little boxes and stuff that you can fill in. But let's say on question 3, if this was a test question that happened to be on a calculator part and you had extra time, of course, you guys aren't graphing these to answer these, so you need a calculator, you shouldn't have that calculator. But if you want to graph this in your calculator, graph this and graph this, there's actually a way to tell your calculator, graph this, but only that part of it. And graph this, but only show me this part. And graph this and only show me that part. I think you guys are just probably haven't seen that before. So what I did was this. So I think is this question 4? Is that the one that's this piecewise function? Number 3? Okay. So you guys have already done this, you already know what the answer is. So look, I said graph this part, and then if you do division, parentheses, only show me where x is less than -3. And that's in here, you have to hit second math to find the semicolon. It's going to graph that part of the piecewise function, and it's only going to show me the part that I want. The last part was 17 minus x squared, and by saying divided by parentheses x greater than or equal to 4, it knows graph this, but only show x values equal to 4 bigger than 4. This is the part I had to look up because I didn't remember this. Graph 2 to the x, but only graph the part where x is greater than -3 and less than or equal to 4. So this is the same thing that piecewise function is saying, but this notation, if you ever want to be able to do this on a graph, or on your calculator graph, you have to know that notation. But then the nice thing is, when you graph it, this was your question 3, right? So when you did question 3, when you checked those first 2 limits, they looked fine. They were approaching the same value. And then the next 2, the middle one was way up here at 9 or 10 or so, and this one was down here at 0. Does that match up with what you said on 3? No?
I think you put 2 to the x instead of 1.
One to the x. Why would you graph 1 to the x? I know, but 1 to the x is always 1. So, okay. You're just making that first piece of the piecewise function, second piece of the piecewise function, third piece of the piecewise function. So what you figured out algebraically, hopefully, is that the middle 2 had a jump because it approached something different on the left and the right, and the middle and the bottom had a jump because it approached something different from the left and the right. This gives you a quick visual to confirm that your algebra is correct. Again, you can't do this in a calculator unless you know that you can do it and you know how to type in those restrictions like that. So I would suggest maybe you practice it once or twice as a way to check your work on a question. This is something I can't tell you how to do on a test. If you want to know how to do it, you got to practice it before. I can't remind you of those things on test days. So. Anyway, I just thought that would be useful at times.
Yeah, there you go. Good job.
It takes so long. And then 3. I don't think it's a 3 is so if the first one was yeah. I don't remember the
How long are we gonna be doing limits and continuity?
Like, how many more class days?
Yeah.
I always try. This is always a tentative date. This is what we've been aiming for. So, next class will be just reviewing, and the class after that will be your quiz.
So technically the unit test?
Yeah.
Okay.
I'm calling it a quiz only because in the grand scheme of what we do in the first semester, I don't like to say this because I don't want y'all to not take this seriously, but limits in the grand scheme of this semester don't matter as much as the rest. So this will probably be like a 20-point assessment, where the other assessments this semester will probably be 50 or 100 points. So this point in the year though is going to impact your grade a lot. But first semester is almost entirely about derivatives and being able to take a derivative, know what it does, and to use it in the real world. Limits, like, you could be terrible at limits and still be great at derivatives, so. Have you had your limit with limits? Is that why you're asking?
No, well, everybody always says that if you skip pre-cal, that the first unit would go ahead.
Well,
I was wondering how much.
but what's the limit as x approaches pi of cosine? Okay, what's the limit as x approaches 5 pi over 4 of cosecant?
What if sine? 5 over 4. 4 is here. Wait.
That sounds right.
Yeah, here, negative.
Uh-huh.
Negative. 1 over.
Nope. See, that's where, like, so unit circle, here's, I think you figured out 5 pi over 4 is here. Sine and cosine are both negative square root of 2 over 2. But cosecant, I asked for cosecant though, which is the reciprocal of that. So you should flip that or put it over 1 like you said. But then you might have to rationalize and say negative square root of 2.
Right. That one would have been hard to do in my head.
You did so much.
I'm not trying to scare you, I'm just saying, like, you say that, like, that, to me, that's a, trying to learn the unit circle in 10, 20 minutes is tough, is what I'm getting at. Students who take pre-cal, I don't know about AP pre-cals, because that's new and I've never taught it. But in pre-cal, you generally learn unit circle early in first semester, like, I think they've already learned it. And then you just use it and use it and use it and use it and use it, so you just get real comfortable with answering
We did
quickly.
a circle in algebra 2, I think, at like the very end.
Yeah, but Just because you saw unit circle doesn't mean you know unit circle.
So I was just wondering about the unit circle.
Alright, what's cosecant of pi over 4 then?
Well, if I had the giant table.
But you don't have a giant table. That was a tool to help you learn it.
Is this number 14?
You'd also know the answer if you paid attention.
So, pi over 4 would be.
Give me one more.
Okay, you really want my image of? Because I can make it when I can't get it. A real question is
This is the square root of 2 over the square root of 2. And then negative
what is
square root of 2.
inverse cotangent of negative 1?
I haven't heard that word yet. I know how to do it, so like quickly.
Oh wait, I have heard that.
So it's asking you what angle has a cotangent of negative 1?
Yeah, that's one.
You're thinking about this entirely too long. Cotangent's reciprocal tangent. If cotangent's -1, the reciprocal -1 is -1. So where's tangent -1, which would be a lot of places, but inverse tangent's only defined from -pi/2 to +pi/2. So you'd have to say -pi/4, but -pi/4 doesn't exist in the domain or range of inverse cotangent. So you need the same value, which is directly across the unit circle at 3pi/4. That's your answer.
I was gonna say.
I'm not doing any tricks that y'all haven't learned. It's just I've done it more times. I'm more comfortable with it. Yeah, so that was going to be your next guess, right?
Right.
Like you said it first.
I know this was you. Guess this was you.
Thank you, and then, so, wherever I go.
It kind of looks like a guinea pig, though.
A unicorn?
A guinea pig?
Oh, I
No,
have
it doesn't.
one that's a bunny wearing glasses, and sometimes if I feel like scholarly, like I do the bunny wearing glasses. Okay.
The K. Oh, don't. I don't know. Oh yeah, yeah, literally. Well, I've replaced it.
But we already have to input the picture. I was here.
Guys, y'all need to sit down.
Yeah, I was.
Randomly in other places. Okay. one reason I like to try to get these papers passed back to you guys, because then the no-name papers, you don't have a chance to actually reclaim them. I think it's the same person. The handwriting looks pretty similar, but both assignments 11 and 13, neither one of these had names on them. So if you turned in both of these today and don't have your name on them, come do the walk of shame, I guess. Are these yours?
Yes. Sorry.
I'll put them in right now, so I don't need them back. Okay, I've been dealing with that for a bit, so let me offer again this assignment 12 that you're focused on first. Is there any of these that you're finding to be harder than the rest you want me to do on the board? Okay. Keep going then. So at the end of class, I will talk about this assignment 14 and how much of this you need to have done by Tuesday. But those of you that are doing well, you're getting it, the answers are working out, everything's going smoothly, you should be able to finish up 12 in class. So if you do finish up 12 in class, just go ahead and start 14. Again, I'll give you more specific directions before you leave, but part of the directions is going to be doing some of it. So you might as well start on it if you get there.
Wait, no, it's like 2 years like no, it's 2 years like 3. the limit is so much. Yeah. I don't know, I disagree with that. I'm not really sure, so I gotta disagree.
As x approaches -1, it will be this one. But
That's strong.
because it's not just the limit does exist. Or when it exists, there would be a jump. The limit didn't exist. So they were approaching and not approaching.
Just do the best you can, like, if you miss it, you can't.
It's approaching 40, but it's -13.
Oh yeah.
It's just built
What did he jump? It was that.
Raz, you just say
Yeah, you're gonna have to help me.
Jacob, no, I thought, lucky me. What? Lucky me, I can nothing can be disabled.
You don't have to. Well, natural.
Jacob.
Oh.
Are you on Wi-Fi?
Yeah, but I have a VPN.
You literally told me this.
So
You just have like your own Wi-Fi.
like, I'm on the Wi-Fi, but I can't log into the
How'd
Wi-Fi.
you get on the Wi-Fi?
I use the password for the Wi-Fi. I've been like auto-connected since freshman year. Jacob, he told me, he's like, just like, okay. Okay. Jacob, my Chromebook's still broken. Buzz, last year during class, Tarman made me leave me like he made, Mr. Tarman made me like take my Chromebook and get it fixed in class. Like during class time, he said I had to go, so I had to get my Chromebook fixed. I lost it.
So now it's good to get cycle backs.
Jacob, all-time number of broken Chromebooks is 3 punch. In page 4.
Yeah, that was right.
Which numbers?
The excuses always were, I dropped it.
Well,
No, I left in OPL and it got stomped on. I don't know who stomped on it though.
how do you know it's not done?
No, so freshman year, I got a little mad at like the code, so I punched my Chromebook and it broke. And the cameras in the school only go back 2 days, so I waited like 3 days, and then I told them that I left in OPL and it got stomped on. It was like there was like it's because there was a big mark in the middle where you could see that I punched it. And the same thing happened last year and the year before. Last year, I broke this screen, but I punched it and it broke, but I just broke it more so the screen wouldn't turn white. Like it was just so gone. And then I was like, oh, the screen died. So they just replaced the screen. But the Chromebook they gave me has like I think it's like I won't use it. 'Cause it's like it's weird. It's like engraved into it. Yes. I only use it for AP tests.
Ln of 1 is 0. Well, yeah, but it's something. Yeah, so you know that.
Wait, is yours outside?
For this one, it's just become it's -4 from the left. Well, okay, so ignore -4. Remember, we don't care what's happening in it. It looks like it's getting -1, 2/3, so closer to 1.
It's rotating.
I think that's a reasonable estimation, yeah. Well, that's very hard to tell. I think you could say a lot of things there. Usually, like, if you come from one side, you can usually kind of tell it's getting closer and closer to 8 or something. But this one, -1 to 2/3 to, I don't know, but it's not undefined. It has nothing to do with that.
Thank you.
You don't have something I can help with?
So, well, yeah, but
Okay. How'd you do that?
I feel like it's good. I don't know why it doesn't. We don't deal with my vodka life. That's so for us. I
You can always see that you have been disabled. It's over, really
Oh, yeah, yeah, because that was the last question. I thought you just.
Guys, you're 10 times too loud. I should need to be able to hear what you're saying. 3, so if I'm going this way on the graph. 3 is very small. This is super big. So that tells me it must be sheer, and that's why I would say infinity.
Okay, so you're
That's
taking an asymptote?
Well, just based on the direction of these wideouts. Really small, really big. I mean, it could be linear. We don't know, but my guess is that it's huge.
So, I know that, but if these are right out of the gates, then how come they?
Well, look, no, from this X value to this X value, that's not a big change. The Y value is going to make a difference. So to me, that sounds like it's down. Sounds like they're approaching like negative infinity. Which is where I got the. That's not wrong. It goes backwards. Bro. 3 to 4,500 is going up so fast.
Maybe it's just
probably going to infinity. You did it in 5 years. You guys should have math.
That's definitely it too.
Is always removed.
Okay, that's what I thought.
Unless, like, there could be a thing, but if the rest of the function is jumping, call it jump. But if there's just a moment it doesn't exist, or a moment it doesn't exist and it's somewhere random, that's removed.
Well, yeah, I guess you were the one who actually thought to look at the garage.
Oh, because as you approach -1 from the left, and you approach -1 from the right. So those are approaching the same thing, but then look at the Y value. At -1, 3. So that spot as a whole is good jumping up. So
Also known as. Oh.
I don't think so.
I'm just checking.
Girl, can I have something over here I can help with?
Very unique camera.
Yes. Oh, wait, yeah, no, that's a 30. So.
-4. I don't care what's happening at -4.
I thought even if there's no point there,
No. Limits don't care about points. Remember when we did the graphs and I said, just like scratch out that X value so you don't look at it? Same thing with the table. If you care about its X approach to -4, this is the distractor, this is trying to get you back on the spot. Don't even look at it. It's all about what it approaches. This isn't a question to do with what's happening.
Evaluate the limit.
Unless you're talking about function and continuity.
And it's what if we combine those problems?
Oh, see, oh. Quickly checking here, things showing up.
Pretty good. This 3 is.
Yeah, it didn't print out great, just, like I told myself.
Is there no question?
You just read the question wrong, you get it wrong, obviously, I would like that, like, that's not something you can just study, so. Moving on to.
So.
You guys got something I can help with while I'm here?
Not too easy. Didn't say that one.
Okay, I think I checked in with everybody, but does anybody need me to come over and help? Okay, please stick with it about another 6 minutes or so before we wind down. We've got 11 minutes of class, so I need you to stay with it. And then in 6 minutes, I'll make sure you know what your homework needs to be. I'll remind you that the quiz is not next class, it's the class after, so you don't have to go home and study a bunch this weekend. But just like I've had under homework, if you feel like you've been falling behind, just because I haven't been pushing the class as a whole to set aside time to study, you probably should still do that on your own. Take that responsibility on yourself.
Of course I am. You know I'm pulling out. Of course. Yes. I'm gonna be probably one of the only guys there, but I'll be there. I'm finna compete this year. Yeah, me, Lane, Colson, and no. Last year what happened was Logan said I was like, Logan, you signed us up. He's like, yeah, I did. And then he didn't sign us up. Yeah, is there like do you have the thing?
Oh, I made it.
Is there like a business one? No, I know, but like, is there like a business? No, I think there is.
Yeah, there's a bunch of them.
There's like some pretty random ones. I remember looking. I'm gonna come look.
Last year I did creative problem solving.
Did you win?
Olivia, Eastwood,
We stacked group.
yeah, we got third.
Is it just, well,
How many people competed?
I think that's
Was that
Makes it dominate the easy field.
saying there's going to negative.
I went to go see my shoulders. Y'all were recycling. Where's my spreadsheet?
You put infinity with this one.
Shoot. Okay. So. One to have cubes. I think I put the nine black out.
I guess just, what's the big
Biomedical debate. That was so light.
Really?
Yeah, it was fun.
Can only one group per school for these?
No, we had two.
Oh.
We have this. Oh, yeah. And also this. Yeah.
Obstacle, it's like quiz pool, but it's about OSEP. You get little buzzers?
Not like this. I get so mad. You gotta read it.
Medical innovation.
Medical innovation.
Oh, exactly.
Yeah. Oh, there's like
Versus negative.
So you can
Innovation, honestly. Because that's probably like, is that like problem solving or?
That took me so long.
What's your position?
I do social media, but no one else really does anything. Like, not really.
Hey, put me on. I was telling him, put me on like, just put me as recruit. Like, I could just be male recruit.
Honestly, like,
But just pull out like recruiting.
recruiting, yeah.
Maybe like a medical innovation. Yeah, no, I need to take that.
I mean, I did it. I didn't have to.
Yeah, I'll be recruiting. So, I could actually do that. So we just come up with an
There's
idea.
2 rounds, so first round you have to come up with the idea, and the second round,
Present.
you have to give it.
Yeah, that's like exactly what we do for FBLI.
Yeah.
So that's fun.
Yes, you guys should do it.
I'll text them. Medical innovation, that's the one. And it's 4 people, right?
Yeah.
Sorry, Logan Cowie.
2 to 4.
It's a good excuse to get him out of it. Oh, sorry, we already had a group meeting. When is it? Is it in the fall too? Like,
No, no, it's in like February.
where is it? Little Rock?
Yeah. I mean, no, Hot Springs.
Ooh. Is there like a conference one too? A conference competition? Like a regional? Or is there, like, that's a state, right?
Yeah.
Is there a regional?
If you place top 3, then you get international.
But there's no regional?
No, it just goes straight to
State? International?
It's in like international.
Where? It's international, it's in Nashville? It's so random.
Bro, my group made it, and then none of us could go. We were all.
That's how we were. We were gonna go to Disneyland in California last summer. Me and Charlie were gonna go.
Yeah, so the future portion is that would be due in like January.
All right, guys, we're down to 5 minutes now, so we need to find a stopping place. Again, before you put everything away, I need you to make sure you know where you need to be for Tuesday so that you're not going to have to play test judge here in the middle of the week. So Diego especially needs to listen. Number 12 should be finished. I think you've had enough class time. You should expect to turn that in when I see you on Tuesday at the start of class. If you've not finished it, if you've not checked your answer, make sure you do that so you can get on the homework form. This number 14, this is the review, and the review just tries to remind you of the different stuff that we've done. So something like limits from a table. There's going to be not 50 of those questions because you've already practiced with some. There's going to be a couple of those questions to remind you what they are and to make sure you know how to do them. You don't have to come with assignment 14 done on Tuesday, but I do ask that you have at least half of it done. It doesn't have to be the first half. You're welcome to just scan through and do the half that you think is the easiest. When I see you on Tuesday, I'm going to start class by asking you which ones you struggled with, which means you put eyes on some of those questions. You start thinking about which ones are easy for you, which ones are not so easy for you. And then I'll have a little bit extra practice. But you need to have at least half of that review done, even if it's your easiest half, to make Tuesday go well for you and to get everything you need done. Okay, and I think I gave you guys a new puzzle yesterday, the rat puzzle. Anybody figure that out? Did I not give you the rat puzzle yesterday? Okay, maybe I didn't give it to you yet.
It was really fun. It was like really easy. Like the testing was like.
No, I didn't give you that?
We didn't read. There was like
Okay, that's fine. I'll share it with you today then.
And somehow we all scored like 80% of them. So we like made it to the second round. And then the question was like, make a triangle, stop, and we made like a whole presentation.
The presentation was so short, it's like, then you don't have to walk either. If it's like something you have to do on the spot, it's easier. You don't actually have to interact. Like for just on the bus, you want judges to fill business terms and just use them in our presentation when we kind of talk about it. So you don't have to practice so much.
I've been 2 years. The first time.
But if it is poison from
You're walking in this year.
Walking in this year.
so then you do 2 of those bottles for 10 hours.
Medical spelling.
You probably know competition. 2 hours a year.
No, because what's the big effect that it has?
What else? There's gotta be some great students.
Oh, there's so there's like
Taking effect.
yes.
I'm sorry to put that, but wait.
0
Okay, I'm
hours,
sorry,
12,
you dropped
2,
like a
to
really
2 hours, 3, 6 hours. 8 hours.
It's so fun. You go to Conway, and there's like, you go into big auditoriums, and then everyone, like, you just stand up and you're like, oh, Israel from Ghana. And then everyone, like, starts attacking Israel, and then,
It's just like.
and then if you win, you get Gavin. It's just long.
Wait, there's a Gavin, you get it like.
Yeah, and then,
I feel like that's for
if you're the first, like, family on their last day, you get to like, interact with like 5 minutes. And it's run by like students at and so they don't know what they're doing and everyone's talking and they hear the thing and it's just like loud as they can. Like they're
That sounds fun. I want to do one of the ones I get.
it's so easy. Like the worst part, like you and then they like call on like different countries to talk about the topic. Nobody knows what nothing happens.
But it's not then the last one is poison.
It's like kids from like Little Rock and like
But if it is poison, then one of those songs.
How do you not have an ID?
I left it at home today, which was upsetting.
Leave it in your backpack?
Well, I accidentally took it in from my car into my house from my car.